Okay, we're going to take a look at 8.3.17. Question deals with, is the diet practical? It states when 40 people used Weight Watchers diet for 1 year, their mean weight loss was 3.0 pounds and the standard deviation was 4.9 pounds. Use a 0.01 significance level to test the claim that the mean weight loss is greater than 0. Based on these results, does the diet appear to have statistical significance, and does the diet appear to have practical significance? Well, the first thing that we want to focus on is the claim. And our claim is that the mean weight loss is greater than 0. And the opposite or negation of that is that the mean would then be less than or equal to 0. And we can take that to write our hypothesis statement, our null hypothesis and our alternate hypothesis. And both involve the mean, both involve 0. And in between the null, it is the equal case, because it's always the equal case between the parameter and the number in the null hypothesis, and it's always the strict inequality in the alternate. And now we're going to do a little bit extra to help set up our conclusion. Put the R in the S, and it is the S that represents the claim here. So down in our conclusion, we're going to talk about whether or not we can support the claim that the mean weight loss is greater than 0. So next we're going to go through, identify the tail of the test. Well, the alternate inequality is pointing to the right, so this is a right tail test. Our significance level is alpha, that's 0.01. And our statistics are up top there, our sample information. So our sample size was 40, the 40 people that went through this, and their mean weight loss in this sample was 3.0 pounds, and their standard deviation of the sample was 4.9 pounds. So that's all of our background stuff. We can now go ahead and write our rule of rejection, and we will reject the null hypothesis if the p-value is less than or equal to alpha. And now we're ready to go ahead and find the test statistic and its corresponding p-value. And I'll just set ourselves up for that here. Now our test statistic, since we're testing the mean, is going to be based on which standard deviation we have. Since we have the sample standard deviation, we're going to be using the student t-distribution. Even if we would have forgotten about that, good news, statdisk was going to bail us out. So let's switch on over to statdisk. And we're going to go analysis, hypothesis testing, and it's a one sample case of the mean. And we've got information to enter. So our alternate hypothesis, it was a right tail test. So there's our choice. Our significance level was 0.01. Our claimed mean was 0. We don't know what the population standard deviation is, but doesn't matter. Sample size was 40. Sample mean was 3.0 and sample standard deviation was 4.9. We can hit evaluate and plot. And what we see here is we see that our test statistic, our t, is 3.872, and that's beyond our critical value of 2.426. So we are off in the tail. We also see that our p-value there is 0.0002, so that's definitely below our significance level of 0.01. So let's bring this back to our question here. So our value for t is 3.782. Let me double check that because I don't trust my memory. 3872. I'm right to not trust my memory. So let's change that. But I did get the p-value right. And what we do see here is that our p-value is indeed less than 0.01. So that allows us to reject the null hypothesis. And when we reject the null hypothesis, we have sufficient evidence to, and now we come back up here, it's the S, so we talk about support the claim that, and then finally we just write our claim as it appeared up there. The mean weight loss is greater than 0. So let's look at that all together. We have sufficient evidence to support the claim that the mean weight loss is greater than 0. So we are concluding that the mean weight loss is greater than 0. We rejected the null. We rejected the idea that the mean was 0. So we go with the alternate that it's greater than 0. And with our questions down here, does the diet appear to have statistical significance? Well, statistical significance comes when we reject the null hypothesis. So yes, the diet has statistical significance. We have sufficient evidence that the mean weight loss for everyone who uses this diet will be greater than 0. What's really kind of the more important question, or just as an important question here, does the diet appear to have practical significance? So if we were to take a look back at our context, we had 40 people using this for an entire year. And after an entire year, they saw an average weight loss of 3 pounds after an entire year. That's not very inspiring given the amount of time and the average weight loss we saw in our sample. Now, if we were to go and take a look at the corresponding confidence interval that came with this, we'd have a little bit better idea of what sort of weight loss we were looking at. But what we'd see in there is even if we got to the high end on that, we're looking at the high end of not even 5 pounds. 5 pounds if we round up to a whole number. So not inspiring. This, I don't think, would make anyone want to rush out and use this diet plan based on the results. But what is important here is that when they go to advertise it, that's what they're going to be using when they advertise it. A lot of times statistical significance will turn into being touted as clinically proven. This program is clinically proven to help you lose weight. And that is not a false statement, but as we see here, there's a little bit more to it than just that, and a very important little bit more to it than just that.